Hello, in this video we're going to look at Cournot when there is uncertainty about firm cost. So here's our Cournot market. The inverse market demand is given by this equation. Firm 1's output is going to be represented by Q subscript 1. Firm 1's marginal cost, MC subscript 1, is $4, constant at $4. Firm 2's output is going to be represented by Q subscript 2. And here's where the uncertainty part comes in. Firm 2 has a 50% probability that its marginal cost will equal $12, and there's a 50% probability that its marginal cost might only equal $6. So let's go ahead and solve this problem. We're going to start with Firm 2. Firm 2's total revenue is price times Firm 2's output. So substituting in our inverse demand from the first slide for P. And simplifying here, multiplying this Q subscript 2 through what's in parentheses. And now taking a partial derivative of the total revenue function with respect to Firm 2's output, we get this result. I'm going to take this marginal revenue now and set it equal to marginal cost. First going to set it equal to the marginal cost when marginal cost is high. And in that case, we said there's a 50% probability that marginal cost will be constant at $12, so that's what I'm referring to as high here. And now I'm going to solve this equation for Firm 2's output, solving for Q subscript 2. So 21 here, I'm going to take 12 over to the left-hand side, so that's why we got 9. And dividing through by 2, we get an output expression, or a reaction function for Firm 2. And now we're going to take Firm 2's marginal revenue and set it equal to marginal cost when marginal cost is low. In that scenario, marginal cost would equal $6, as was given on the first slide. And doing a similar thing, we're going to solve this for Firm 2's output. And we have this expression. This is the output reaction function when Firm 2 has low marginal cost. All right, let's move on to Firm 1. Firm 1's total revenue is price times its output. Things are a little bit more complicated here. What is price? Well, it's going to be our inverse demand, 21 minus output of Firm 1, minus the output of Firm 2 if Firm 2 has high marginal cost. And notice there's a 50% probability of that happening, so I'm putting in 0.5 here times price under the scenario that, again, Firm 2 has high marginal cost. And then there's a 50% probability that Firm 2 will have low marginal cost. So that's where this 0.5 is coming from. So with low marginal cost, the inverse demand is 21 minus Firm 1's output minus Firm 2's output when it has low marginal cost. I'm going to just simplify some things here. We're going to take this 0.5, multiply through it by what's in parentheses, along with this Q subscript 1, and do that over here as well. So just simplifying some things here. So next step, we can take a derivative of this total revenue expression with respect to Firm 1's output, and we'll get this result here. Setting that marginal revenue equal to Firm 1's marginal cost. Firm 1's marginal cost is only 4. We get an expression for Q subscript 1. And again, recall from our first thing we did with Firm 2, we got a couple reaction functions for low marginal cost and high marginal cost. I'm going to substitute these expressions into Firm 1's reaction function. So making the substitutions down below here. Simplifying mathematically. Further simplification. And finally, we get firm 1's output at 7.33 units. Plugging that 7.33 into firm 2's reaction function under low marginal cost or high marginal cost. For low marginal cost, firm 2's output would be 3.835. Under high marginal cost, it would be 0.835. So our ex-ante equilibrium strategies are given by these quantities. Once the game is played, however, firm B will know its cost and one equilibrium outcome will exist, either 7.33 and 3.835 or 7.33 and 0.835. Okay, I hope you found this video helpful.